Hello and welcome to this tutorial on line balancing. Now before we get on with numericals on line balancing, let us understand what is this concept. This concept of line balancing is, suppose you have an assembly line wherein you have certain machines installed which are working in an assembly line. Suppose those machines are called A, B and C. Now you have first machine which can transform 10 units per hour. You have second machine which can transform 5 units per hour. Then you have third machine which can transform 10 units per hour. Now here is where I start with my assembly line. Input comes over here, it gets transformed on A, moves to B, from B it moves to C, and then I get my output over here. Now if you have a look at this assembly line, think very practically. What will be my maximum output per hour? What can be my maximum output? Now first thing, if you have a figure of 10 plus 5 plus 10, 25 in your mind, that is completely wrong. Why is it wrong? Because these are machines that are connected to each other. They are not working as standalone workstations or machines. So I cannot say that I get 10 units from A, then I get 5 units from B, so 15, then I get 10 units from C, so I get 25. No, they are not working as a standalone system. Rather, they are working in an assembly line. What happens in assembly line? My input comes on A, raw material. From A it gets transformed, and A can transform 10 units an hour. So in an hour we get 10 units over here. Now B gets these 10 units as input, but it can transform only 5. So what will be output of B? It will be 5. And now C can transform 10 units, but it is getting only an input of 5 units. So it will transform these 5 units in output. So do we see? My output would be 5 units per hour. So what has happened? I was having a very good machine of 10 units per hour, another good machine of capacity 10 units per hour, but a slow machine of 5 units per hour also was there. And now as a result of this, I'm stuck with it. As a result of this, what has happened is that my efficiency of complete line has come down. This could have done 10 units. It was doing 10 units. But because of this, only 5 came here. And as a result of this, though C was having a capacity of 10, it transformed only 5. So this B, this machine is my bottleneck machine. Why bottleneck? Because it is stopping the flow of my output. It is restricting my output. So how do I remove this bottleneck? Just imagine if I had another machine B. So of these 10, 5 would go here, 5 would go here, 5 are coming from here, 5 are coming from here. Every hour what is happening? 10, 5, 5 distributed, 5, 5 again coming out and going to C, C getting 10 units, and my output would be 5 from here, 5 from here, 10 in an hour, 10 units an hour can be transformed. So my output would be 10 per hour. So what I've done is, this act of adding this new machine is known as assembly line balancing. This act of adding this new machine is known as line balancing. Why line balancing? Because I have troubleshooted my bottlenecks and now I am working at a higher capacity. See, all my machines had a higher output rate, but because of one machine I was stuck at lower rates. Now after this assembly line design, my output is at highest possible level. So this theoretically is the concept of line balancing. Why do we go in for line balancing? We go in for line balancing so that my machine, so that my assembly line works at best possible speed, best possible capacity. Here you see some cards related to the video you just watched. Feel free to browse across them. Please do leave your queries and suggestions in the comments section below. We would try to address them and learn from them. And do press the subscribe button below if you have not already subscribed. Thanks for watching. Bye bye.